Here's the given information. This length and this length are the same, and this is parallel to this, which means this angle here and this angle here will be the same. Those are the key informations that we need to know before we get started. So the first thing I'm going to do is label these A, B, C, let's make a nicer B, B, C, and D. I'm going to calculate angle D first here because I have it inside this triangle. And so D is equal to cos inverse of the adjacent sides, 11.3 squared plus 8.9 squared minus 11.7 squared all over 2 times 11.3 times 8.9, which tells us this angle is roughly equal to 69.6 degrees. So we have 69.6 degrees. Now I'm going to calculate this angle C and angle B. Well, actually the small part, so here, this angle in here, which I'll call it maybe C1. So C1 is equal to, using the sine law, sine inverse of its opposite side, 8.9, times sine of another known angle, which we just found out is 69.6, over the opposite of that angle that we just used of 11.7, tells us that C is roughly equal to 0.5. Okay, so in here is 45.5, which means here is also 45.5, and this angle in here, which I'll call B1, let's make that nicer, that will be equal to 180 minus 69.6 minus 45.5, tells us that B1 will be equal to 64.9 degrees. So here is 64.9. So that's not the total angle. We don't know part of it. So now we have to figure out this angle here, A, and this angle, the small one in here. So to do that, I'm going to use the sine law because I have 8.9 over here. So let's calculate this angle A. And so angle A will be equal to sine inverse of its opposite side, which is 11.7, sine of the angle that I know, which I know this angle here, so 45.5, over opposite to that, which we know is 8.9 because it's a regular trapezoid. So this angle A is roughly equal to, and log's ambiguity, we can get 69.7 or 110.3, and clearly this is greater than 90 degrees, so we'll be using this version, the 110.3, which means, so this in there is 110.3 degrees. So this angle down here will be equal to, so I'll call that C2, will be equal to 180 minus 110.3 minus 45.5, which equals 4.2 degrees. So let's put this all together now. Take a little bit of work, but angle A is equal to 110.3. Angle B, which is right here, is 45.5 plus 69.9, which is equal to 110.4, which these two are basically the same because of rounding, they're a little bit off, which makes sense because it's the same length. So angle C is 69.6 degrees, and angle D is equal to C2 plus C1, which gives us 69.7 degrees. So 69.7 degrees. These are basically the same just due to rounding, which makes sense that these two should be the same and these two should be the same because these are two large angles, these are two small angles in a regular trapezoid.